would only be 0.35% higher than the vacuum field. Because if psi of m is 3.5 times 10 to the minus 3, that means that the field inside is only 0.35% higher than the vacuum field. But that is enough for liquid oxygen to be attracted by a very strong magnet, provided that it also has a very non-uniform field outside the magnet. And so, the force with which liquid oxygen is pulled towards a magnet can be made larger than the weight of the liquid oxygen. And so I can make you see today that I can have liquid oxygen hanging from a magnet. And that's what we're going to do here. Make sure I have the right setting. Ah, this is it. So we're going to have some changes in the light. So there you see the two magnetic poles. It's an electromagnet. And so we can turn the magnetic field on at will. So here are the poles of the magnet. And the first thing I will do is very boring. I will throw some liquid nitrogen between the poles. Now, I don't have the value for liquid nitrogen there, but nitrogen is diamagnetic. So it's not even an issue. Diamagnetic material is pushed away from the strong field. So even though the value for psi of m will be very different for liquid nitrogen than it is for gaseous nitrogen, it doesn't matter. So certainly it will be pushed out. That's the first thing I want to do, just to bore you a little bit. Because I have to keep you on the edge of your seat before you're going to see this oxygen which will be hanging in there. So let's first power this magnet. I hope I did that. Yes, I think I did. And here comes the liquid nitrogen. Boring like hell, it just falls through. Now comes the oxygen. Liquid oxygen. It's hanging in there. I challenge you, you've never in your life seen liquid hanging on a magnet. You can tell your parents about it, and of course your grandchildren. It's hanging there. I'll put some more in. Make sure I have the right stuff, yeah. Put some more in. There is liquid oxygen. When I break the current, it's no longer a magnet. It will fall, of course. Don't worry, you'll get more. Who has ever in his life seen a liquid hang on a magnet? It's paramagnetic, it's not ferromagnetic, but because the density is so high and because it's so cold, the value for psi of m is high enough that the force on it is larger than its own weight. If you do this with aluminum, not a chance in the world. Aluminum will not hang in there, even though aluminum, as you can see there, is paramagnetic, but the value 2 times 10 to the minus 5 is way too small, and it will not stick to a magnet. Okay, you have something to think about. I'll see you Friday.